All right, so proportionality and constant of proportionality. So by now we've watched quite a few videos on constant of proportionality. And we already know that a proportional relationship just means that two ratios are equivalent. Okay, that's just what a proportion is. It's two equivalent ratios or two equivalent fractions. So what is a constant proportionality? To sum it up, it's basically a constant ratio in any proportional relationship. We're going to talk about that in a little bit more depth. You already saw the Khan Academy videos, but I'm going to show you what it looks like in these slides too. Also, constant proportionality is basically another name for unit rate. Constant means that it never, ever changes. Okay, if something is constantly going on, it means it's going on always. So we're always able to write out our constant of proportionality as an equation that looks like this. Think of x and y as your points, okay, or your parts of your coordinate. When I have a coordinate, it's literally parentheses x comma y, close parentheses. So there's a relationship between x and y when we're talking about proportional relationships. It's telling me that in order to get y, you need to multiply x by something, okay? We actually did this in the last unit when we discussed scale factor, okay? We use the scale factor, which could be k, and we multiplied it by a side to get a new side. See how these are related to each other? So if I had a scale factor of 2 and I multiplied it by a side that was 3, 2 times 3 gives me 6. Okay, that would be my new side. Notice there's no addition or subtraction. The second you add or subtract, it's no longer a proportional relationship. Okay? And k will always be our constant in proportionality. When we're talking about k, y equals 45x. In this example, 45 is our constant of proportionality. Okay, it's basically saying that I multiply x by 45 to get y. The constant of proportionality is just a number that you're multiplying by another number to get a different number. That's it. That's all you're doing. So in this case, find the constant of proportionality and write it as an equation y equals k times x. So how do we do this? We're looking at this table, right? And it says use swirl frozen yogurt. In the first column, we have the weight per ounce. And in the second column, we have the cost. So we're looking at a relationship between the two columns. Okay. Let's pretend, well, first of all, let me give you context to this. When you go into a frozen yogurt shop, okay, a lot of times, most of these places, they'll give you a cup. You'll fill it up with whatever you want, frozen yogurt, toppings, blah, blah, blah. And then they weigh it, right? And then whatever your weight is tells you your cost. So a way of looking at this table and a way of looking at most tables is this first column is your independent variable, meaning that number stands alone, right? When I put the cup on the scale, that's my weight, okay? The weight doesn't depend on another number. The weight just depends on the fact that you put all these toppings in a cup with the froyo and you put it on the scale. Now, that's independent. In the second column, you have what we call the dependent variable, because think about it. The cost of your froyo depends on the weight, right? It depends on the weight. So when I go to a froyo shop again, they weigh my froyo and then they say, oh, it costs $5. Okay. So I end up paying $5 because of the weight. Cause, effect. Okay. Now, when you're looking at your constant of proportionality, to check this out, you're going to make a ratio. You're always going to make a ratio where you're comparing your dependent variable to your independent variable. So it's going to be, in this case, your cost over your weight or to your weight. So if I set this up, I look at it as $1 over 5, $2 over 10, $4 over 20. Now, if I keep going 1 over 5, 2 over 10, 4 over 20, as long as the ratios are equivalent to each other, then this is a proportional relationship. And I can check this. I already started this off. $1 divided by 5 gives me 20 cents. $2 divided by 10 gives me 20 cents. This is my ratio. I could have done 2 over 10, but again, or 1/5. I could have reduced 2/10 to 1/5. I could have reduced 4/20 to 1/5. Okay, if I wanted to keep it as a fraction. Because we're dealing with money, I decided that I would change it into a decimal. Because 20 cents makes sense, right? You can actually understand that that means 2 dimes or 4 nickels or 2 nickels and a dime. Okay. So because all of these ratios are equivalent to each other, they all equal 1/5 or 20 cents. This is a proportional relationship. And that's how you can tell off of any table. You always take the second column, which is your y of your coordinate or your dependent variable, and put it over your x or your independent variable, which is in the left column. So 1 over 5, 2 over 10, 4 over 20, they all give you a fifth. Let's look at this. I don't understand anything about Minecraft, but sure. Let's say in Minecraft it takes you, I'm assuming 3 minutes to build 45 blocks, 7 minutes to build 105 blocks, and 10 minutes to build 150 blocks. No idea what blocks are used for, but cool. Building blocks? Sure. Anyways, so now you're going to do the same thing, right? If I want to figure out if this has a proportional relationship and what my constant of proportionality is, which apparently I forgot to discuss in the last slide, it was 20. You're going to do the same thing. 45 over 3, 105 over 7, 150 over 10. Are you going to get the same thing? Well, yeah, you get 15. 45 over 3 gives me 15. 105 over 7 gives me 15. 150 over 10 gives me 15. So my constant proportionality in this case is 15, and I can write my equation as y equals 15 times x. So these blocks, this column is my y. This column of minutes is my x. So if I multiply 3 by 15, I get 45. 7 times 15 is 105. 10 times 15 gives me 150. Okay. Notice there's no addition or subtraction involved. It's just direct. 3 times 15 is 45. Directly. 7 times 15 is 105. Okay. There's no addition or subtraction involved. It's just multiplication, just like when we were dealing with scale factors. Baking. Okay. I have my minutes and my cookies. After 11 minutes, I can bake 22 cookies. 12 minutes, 24. 30 minutes, 90. I don't know how realistic this is. I don't bake, but cool. So now we look at it. What happens when I divide 22 by 11, 24 by 12, 90 by 30? Do I get the same ratio? Well, 22 divided by 11 is 2. 24 divided by 12 is 2. 90 divided by 30, however, oopsie. There is no constant proportionality because there is not a constant rate, okay? In this case, 90 over 30 gives me 3. These gave me 2. The ratios are not the same. 20 over 11, yes, is equivalent to 24 over 12 because they both give me 2. But 90 over 30 gives me 3. The ratio is not the same, so there is no constant proportionality. Again, if I want to look at the other way, 11 times 2 is 12. 12 times 2 is 24. If this were proportional, then I would be able to say that 30 times 2 equals, well, it doesn't equal 90, it equals 60. So this threw it all off. So there is no constant proportionality. The perpetrator. It's okay. Now, on a table, let's talk about on a table. I mean, sorry, a graph. Duh, this is a graph. Haha. It's been a long day, I apologize. So on a graph, how do I figure out whether or not my relationship is proportional? Well, I can look at it and tell whether or not it's proportional. First thing, does the graph start or go through the origin? Remember, the origin's right here where both of the axes meet. This is point 0, 0. I know there's a little space here, but that's because I couldn't get this to cut through exactly. Yes, it does go straight through 0, 0. The other way I can tell is if it goes through 0, 0, it also has to be a straight line, meaning it's not going all over the place like this, okay? There's no little mountains or peaks or whatnot going on. It's just going constantly at the same rate. So how do I find my constant proportionality? Well, I do the same thing. I already put out points, and I can tell where the points are because these red dots are where two lines intersect. So if my graph went through this corner where these two lines intersect, that would be a point. Like up here, this line and this line intersect right here. So this is a point. Same thing here, 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 and here. So let's choose 2 points. I have 2, 6 and 4, 12. Okay, so let's check and see if my ratios are the same. Remember, you're going to take your y and you're going to put it over x. Well, 6 over 2 is 3, and 12 over 4 is 3. 18 over 6 is 3, and I can keep going, and I'm always going to get 3. So my equation would be y equals 3x, because my constant proportionality is 3. And again, y is the cost because it's on the y-axis. See how it says cost here? That's how I know what it represents. My weight is on the x-axis. It's down here. So I know that all my x's are weight. So again, the cost depends on the weight. Let's look at this one. Does this go through the origin? Yes. Is this going straight up? Yes. So already I know it's proportional. So let's figure this out. Where in the world is this point? This is going up by 2's, 2, 4, 6, 8, 10. 10 over 2 gives me 5. If I go up, this is 18, so this is 20. 20 over 4 gives me 5. 30 over 6 gives me 5. And 40 over 8 also gives me 5. So my constant proportionality is, you guessed it, 5. So k is 5. When I rewrite this, I get y equals 5x. And this time, we're talking about gallons versus cost. The number of gallons is the independent variable, and the cost depends on how many gallons you end up buying. Uh-oh. What about this one? Is this one proportional? Well, it goes through the origin, but does it keep increasing or going up by a constant rate? No, right? It's got all these little corners and stuff. So already I know that it is not proportional, and I can test it. Let's look at this first point, 6 over 2. That gives me 3. Well, the next one is 12 over 6. Well, that gives me 2. I had 3 here, 2 here. Are my ratios the same? No. There is no constant proportionality. This is not going up at a constant rate. So remember, if two quantities are proportional, then they have a constant ratio. And you can find that ratio by comparing y to x, just like we did back here. I compared the y, which was 6, to the 2, which was x, and I got 6 over 2. I got 12 over 6. And then I compared the two. Is 6 over 2 the same as 12 over 6? Well, no. This gives me 3. This gives me 2. To have a constant ratio means that the two quantities have the same unit rate, which is why we divided them out, right? If the ratio is not constant, the two quantities are said to be non-proportional, okay? They are non-proportional. So the two quantities do not have the same unit rate. Proportional relationships, they're always going to go through the origin, okay? They always go through the origin. Remember, the origin is the point 0, 0. So if your graph does not go through 0, 0, it is not proportional. Further, your graph has to be a straight line, okay? And it has to be the combination of these two things. It can't just be a straight line to be proportional. It has to do both. It has to go through the origin and be a straight line. So what about these? Let's assume that, well, we're not assuming, it says y. I know it's tiny, but if you get closer and you use a little microscope, you can see this says y and this says x. Left my magnifying glass in my other car, so not that I'm working out of my car, but still, that's okay. So does this go through the origin? Yes. Is this going up at a constant rate? In other words, is this a straight line? Yes. So is this proportional? Yes. What about this one? Does this go through the origin? Nope. Already I know this is not proportional. So let's look at this one. Do this on your own. Is this proportional? Survey says yes. What about this one? Ignore the stuff on the left. Yes. Now let's look at this table. Here's what I want you to do. The following chart or table shows how much money Alex earns for mowing lawns. And the amount of money he earns proportional to the number of hours that he spends mowing. So go through this table and let me know. In fact, fill it out. So as I'm doing this, 14 over 1, this is my unit rate that I'm working with. The rest of these should be 14 over 1 if this is a proportional relationship. Well, 28 over 2 is 14 over 1. 42 over 3 is 14 over 1. But is 56 over 4 the same thing as 14 over 1? Yeah, betcha. Yeah, it is. So there you go. Okay. This is how you would do it with a table. That's about it. We know how to identify it from an equation. It's always what k is. So it's always the number that's in front of the variable of x equal to y. We know how to tell on a table, which we just did, and we know how to tell on a graph. Same way we do the table, except it's on the graph and we pick the points out. So that's it for proportional relationships and constant of proportionality. Again, in this case, 14 is my constant of proportionality. If you have any questions about this, let me know. And that's all.